Hello everyone, welcome to my YouTube channel. Today we are going to talk about how to set up Jupyter instance on a Amazon Web Services EC2 instance. In this video, I'll be just first going through a slide quickly in which I'll talk about what is AWS or Amazon Web Services, what is AWS EC2 or Elastic Cloud Compute, what is Python and Anaconda, what is Jupyter, and how to set up this process. So let's start with the presentation. So what is AWS? AWS stands for Amazon Web Services and it's a subsidiary of Amazon, the e-commerce company. Almost most of the people seeing this video might have at least heard about it or might have even bought something from it. It provides on-demand cloud computing platforms to individuals such as us, or companies, or governments on a paid subscription basis. Now, this company was founded almost in the beginning of 2006, and for almost 7 years, there was no stiff competition from any of the other vendors because most of the other vendors thought that cloud is not so big, and this gave AWS a really big head start, and it is a dominant player in the cloud market with almost more than one third of the market share. The next three players are Microsoft, Google, and IBM with 11, 8, and 6%. So you can imagine the scale difference between all these cloud vendors. So the AWS technology is basically implemented in server farms. So you can think of uh, big farms or big uh, infrastructure uh, buildings in which there are servers racked there, and these are maintained by Amazon. And what Amazon does, it basically rents out these servers to us. Let's say there's a big server, they will rent out some of these big servers in smaller chunks using, let's say, virtual machines. And fees are basically based on a combination of usage, the type of hardware we are looking for, whether we're looking for smaller RAM or high RAM, whether looking for a simple CPU based instance or GPU based instance, and whether how much money or how many number of hours we are going to commit for this particular usage. In 2019, AWS has more than 150 services spanning quite a bit of range, including computing, storage such as S3, networking, database, analytics, application services, deployment management, mobile, developer tools, tools for IoT, machine learning, AI, and host of other things. You can check the website. The most popular services still remain Amazon Elastic Compute or EC2, the one that we are going to use in this video, and Amazon Simple Storage Service or H3, which is used for storing files or media or anything, any file on the internet. So as I mentioned, AWS EC2 is one of the most widely used services for AWS, and it forms a central part of Amazon's AWS's cloud computing platform, and it basically allows users to rent virtual computers. So think of our computers, the one that you're just looking in front of you, as a computer. And what Amazon does is it rents out virtual machines like that, uh, which we can rent by paying a small or nominal fee. Users can boot an Amazon machine image to configure a virtual machine, which Amazon calls an instance, and hence you'll be listening that word a lot from me or everyone else that uses AWS. A user can quickly create, launch, and terminate server instances as needed, paying by its second for the active servers, and hence the term elastic. So before AWS, most big companies or even the smaller ones rented out or had the servers on their local, and this had a couple of drawbacks. The first is, let's say at any given instant there the server capacity was fixed, and to let's say if there's a requirement of increase in 10% or 20% of this capacity, it was not possible, and it has to be taken into account beforehand. All the servers had to be bought, installed, and looked after. With these cloud services, that was no longer a a good option because companies just needed to pay for the capacity that they rented, and they could basically increase almost infinitely uh, and scale it up. And if there was no usage, they can cut down, which was again not possible with the local virtual centers, because if there's some capacity that is not used, it's just not used, and it's something like a waste of money. The following categories of instance are particularly being available right now. So the general purposes instance, which mostly people use, compute optimized, then we have memory optimized, then we have accelerated computing, which are the P and G instance, which are used for deep learning or image processing or image rendering. Then we have the storage optimized, and we can pay either by on demand, so if we pay by the hour without any commitment. So if we use a particular instance, we can see how much we are going to pay per hour. I can show after this slide. Then they have reserve instances where uh, the users rents out with the one-time payment, and these are mostly big corporations renting out AWS, and they give heavy discounts against this commitment. And then there are spot instances. Now, again, even though Amazon has done a lot of forecasting, a lot of their servers are lying idle. What they do is they don't want that to lie idle. They give out huge discounts and give them as spot instances. The only catch with this is they can recall these instances if there is an increase in the on-demand capacity, and you just have 2 minutes to store all your work, uh, or hibernate that instance and then restart that again. So a lot of big companies, Netflix, Lyft, and all those big companies, they use these spot instances to run their uh, batch processing jobs. I'll talk briefly about Python and Anaconda because we'll be using Python to run the Jupyter Notebook. So Python is an integrated high-level general purpose programming language, and it was created by a guy called Guido van Rossum and was first released in 1991. And it has become one of the most widely used programming languages worldwide, mostly used after Java and C, C++. And it's the most widely used programming language for machine learning and AI or deep learning based technologies. It's available in two versions, Python 2.x and Python 3.x, and the community is moving mostly towards Python 3.x. Although we have a lot of legacy code in Python 2.x, but the support for Python 2.x will stop after 2020. There's a couple of syntax differences between Python 2 and 3, but mostly it remains the same. I will say if you're starting with Python, you use Python 3. Now, Python by default comes if you're using Windows with the idle uh, working environment, which is very easy, but then very naive. What Anaconda does is Anaconda is a free and open source distribution of Python and R programming languages, which mostly aimed at scientific computing, such as machine learning or data science or large scale analytics. And it basically aims to simplify package management and deployment. Anaconda by default comes with around 1400, 1500 packages, so most of them are already installed. We don't need to install them. And some of the packages run really fast if they're running on Anaconda because I think they're optimized. The default version for Anaconda 2 is Python 2.7 and Anaconda 3 is Python 3.7. However, we can create the virtual environments as in needed. For example, let's say if we need to have TensorFlow or PyTorch or some other Python modules, we can install using the virtual environments. Now let's talk about Jupyter Notebook. If you have used RStudio, you might be aware how fantastic is that platform. We can run the commands one by one, and we can access the variables that we used a while earlier. A simple program in, let's say, Sublime Text or any other notepad editor is not so good to debug, especially when doing some machine learning or some iterative process. So that's where the Jupyter A notebook came in. It started as a IPython notebook, which was quite famous, and it's a web-based interactive computational environment for creating Jupyter environments. It's basically a bunch of JSON commands running in the backend, and it follows a version. And what it does is basically whatever commands we input into the in the IPython terminal or the cells, it's basically run against a Python server, and the output is basically again given out there. So you can see there's a small background here on how exactly uh, the Jupyter notebooks look like, and we will see that shortly. But it's just a small version here. Now, to set up a Jupyter instance on a AWS EC2 instance, first of all, we need to have AWS account. If you don't have a, you should create one. AWS is gracious enough to give a free tier which has 750 of monthly hours of some AWS instances, mostly T2.micro, which should be enough to learn that. Then we have to create, launch, and connect to the EC2 instance, preferably the free tier one, the one that I'll be using for this tutorial. Then we have to download and install Anaconda, and we can then either create and activate a virtual environment if needed. I'll not do so for this particular tutorial. Then we'll be creating a password for this Jupyter notebook, which we'll be using to access and making it safe so that it doesn't go to anyone's hands. Then we will create a configuration file for the Jupyter and certificates for supporting HTTPS. And then we will configure Jupyter via the configuration file generated above. And then we'll run the Jupyter using a screen. So this is what we will be doing in this video. So before going forward, I'll quickly see the AWS pricing. So as I mentioned, it has a AWS free tier, and then it has the on-demand and spot instances. And if we go to on-demand, we can see there are multiple instances type and the pricing that Amazon has for different regions. If we look at US East, A1.medium, it has 0.0255 per hour, which is pretty cheap. So you can see the different pricing for different instances on this URL, aws.amazon.com/ec2/pricing/on-demand. If you don't have a AWS account, I will suggest to create one. If you already have one, then I will suggest to log into that. And this is the dashboard or the console for AWS. And these are the different services that Amazon provides: compute, management and governance, AWS cost management, storage, database, and machine learning, and other things. For this purpose, we'll be using EC2. So I'll click on EC2. And right now I don't have any running instances. So I need to create one. It's very easy. All we need to do is basically click on this launch instance. And there are different AMIs or Amazon Machine Image. What Amazon has done is they have taken a snapshot for a particular build, and you can use that snapshot. So for example, for this one is a Ubuntu specific server. This is a Linux based server. This is a Red Hat based Linux server. They also have a specific Amazon EMI, which has Postgres, Docker, and PHP and other packages. They also have a Windows based server. They also have a deep learning based EMI uh, that's available. uh, I'll be using a free tier based service. So right now I'll be using Ubuntu 18.04, and I'll be using a free tier that's available in T2.micro. I need just one instance, so that will remain one. So the VPC is basically a way to configure within Amazon your own private network so that there's no in and out traffic from your VPC to any other network. This is a way to make sure that there's no way that someone else can access your data that is very private to you. And so is the subnet. The IAM role, again, I'll not go. IAM role is basically the privileges given to this machine. Let's say you want to talk to S3 bucket or something else, then can give IAM access so that if there's someone is you don't have to make everyone an administrator. Let's talk about storage. So we can give we will keep the default as 8 gigabytes. We can add the tags. So tags are basically a way of tagging the particular instance. So let's say your company has 3 or 4 departments or n departments, and each of them have their own access to EC2, and you want to, at the end of each month, understand how much working hours or how much cost they're incurring for each department. We can use these tags to do that. For this purpose, I won't be doing any tags. Uh, the the configuration security group is basically what are the what are the protocols that this instance will have. So, for example, we need to SSH into this machine. I already have one created, so I'll use that. Then we need to also open the HTTPS port, and we will open the 8888 port using which we will run our Jupyter instance. So we will do that, and then it will ask to review, and we can then, I think everything looks good. It will say basically the instance is open to the world because we are given such permissions in the security group. That is the launch wizard one. I won't be talking much into that in this video. If you want to understand more on security groups, I suggest uh, watching a video on YouTube and understanding what exactly that means. But for this particular video and for launching your particular Jupyter instance, Jupyter notebook, this should be good enough. So we say launch instance, and it will ask for a key pair. So key pair is basically a public key that AWS stores on that particular instance, and a private key that we have. If you have used PuTTY before, or if you have worked with PEM files on Ubuntu or Mac, you'll know what I'm talking about. For this purpose, I do not have existing pair. I will create a new pair, and I will name that Neo, and I will download that key pair. So this is downloaded, and I'll say launch instances. So this instance is launched, and AWS is pretty quick. It's right now in pending stage, and it will be in a running stage in no time. So while that is happening, I can quickly walk through what's the description. So there are a couple of tabs that Amazon provides here. So there's the instance ID. So each instance ID is unique. This is the instance state right now. The instance type, we have the t2.micro because that's a free tier. And this is the availability zone. So our instance is running in US East 1B. These are the public and private IP. Once our instance starts running, it will be self-populated. So right now our instance is running and we can connect. And this is the public IP. So let's start. Let's connect to the instance. So I will open a Jupyter a terminal, and I will. So yeah, this is my PEM file. I will give the proper permissions to that, and clear. Now let's connect. Let's connect to that instance. This is the IP. So we'll copy that, And the username we have to provide for Ubuntu base instance, it's Ubuntu. If there's a CentOS base instance or AMI, it's EC2-user. For this particular purpose, we will use this. And just press enter. It will ask if we need to add the key fingerprint. We'll say yes, and this should let us connect to the machine. So now you can see we are connected to the instance. So once that is done, the next step is basically to download Anaconda uh, Python distribution onto this particular instance. For this, we will go to Anaconda's website and download from there. So I'm looking for Linux-based instance and Python 3.7, and then the 64-bit installation. I'll copy the link and use a famous wget, and it will download that really fast. So while that is happening, I'll go to the next one. So I think it's already done. The next step is basically to install Anaconda, which is done using the bash. And then Anaconda, we need to press enter, and this is the user license that we never read and always press enter. So I'll do the same here. And the next, it will ask whether we agree to all these terms and conditions that they have, and I will obviously say yes, and I think so will you. I'll say yes, and so now what it's saying, Anaconda will be installed at a particular location. By default, I will say yes, that's the location I want. I don't want to use anything else, and hopefully it will ask to add our Anaconda installation to the path variable. If it doesn't ask, we have to do that manually. It's now installing the required modules for Anaconda. So you can see it's installed Python 3.7.1. BLAS is a library for linear algebra, and there are other by default libraries that come with the Anaconda installation. So this will take a while. While that happens, we can uh, we can see what other things are there on the Anaconda distribution. So this is the open source Anaconda distribution, and easiest way to perform Python and R data science and machine learning on Linux, Windows, and Mac OS. It has almost 1500 plus data science packages, a very easy way to and one-step way to manage libraries, dependencies, and environments. We can then train and develop models based on TensorFlow, Keras, analyze data sets using NumPy, Pandas, and then train models using scikit-learn, and quickly visualize models with Matplotlib, Bokeh, and other modules. And it's really easy to install. As I said, if you have a Windows-based instance, it will have a exe file that we can download. If you have a Mac OS, it will have a PKG file that we can use to download that. So hopefully this happens really fast. You can see there's tons and tons of packages that are getting installed while we make this video. There's a Python installation that just happened here. Jupyter is by default installed, and once that is done, we will then add the path variable if it doesn't get installed by default. It installed just scikit-learn to 0.20. I will pause this video and will come back once this installation is. Oh, so I think it's done. So what it's asking to do is to install it to initialize Anaconda 3 in your home Ubuntu bash RC. I will say yes. And thanks for installing Anaconda. It's now asking me to install Microsoft VS Code, I will say no. I don't want to install that. And it looks like it didn't ask to add the path. If so, we have to do that ourselves. So that will be home, Ubuntu, Anaconda 3, and then bin. So this is how we do that. Now, if we say which Python, it should act. Oh, I think I should not have added this here. So now if we say which Python, it will give that address. The next thing is to create the password for the Jupyter notebook. And for this, we will start IPython terminal by doing IPython, which is really easy. And then from ipython.lib import pass wd, and then we say pass wd, which will ask to enter a password. Now this is really important that we save this password, and this is the SHA key that gives. Again, we'll be using this SHA key shortly, so don't forget about this. And the work here is done. So let's exit this. The next thing is Jupyter is already installed because we have Anaconda. Otherwise, we would have to install it. So Jupyter notebook minus generate config. So this is the command to generate a configuration file for Jupyter, and by default it writes to the home ubuntu.jupyter directory. Once that is done, we need to create the HTTPS certificates. So we will create a directory called certs. We'll go to that directory, and then we will install OpenSSL rec and other libraries here that are required for this, and provide the configuration for this. So this should be good. I'll just check the command. This command is sudo openssl rec minus x509 minus nodes minus days 365 minus new key RSA 1024 minus key out mysert.pem minus out mysert.pem. Looks good. Let's press that. It'll ask for some country code, state, province. You can enter that, or you can just press enter, and the work here is done. The next step is basically to uh, uh, to give permissions to this folder and everything inside, and let's see if that is done. And looks like yes, that should be done. Next, let's say let's move in the Jupyter directory that's there, and here is the configuration file, and we need to make some changes. The first is get me the current config. So this is a Python file, and this is run every time we start the Jupyter notebook. So this will get all the configuration, and all we are asking is we want to change some of these and I should had written this before, but I have made my own notes and using them. I'll be copying this and pasting on my blog so that if you don't have to type it here. Now here I saw multiple options, one star and all 0.0.0 and star. For me, 0.0.0 work, but it might be different for you. So I'll be using this. You can use that or star, depends on whatever you want to do. Then we want to say that we don't want to use the browser because it's running uh, on a Ubuntu based headless environment, so we don't want to run this open the browser there. And then we need to give the password that we just provided, the SHA password or the key, and we will place that a little while later. We can copy it from there, and then we need to provide the port, which is 8888. So remember, we had that port open initially in the security settings. So let's save that. I press escape, colon, W and Q, and then enter. That's there. And we need to copy this particular SHA key over there. And remember the password that was used. So I'll go again here. I'll go into the edit mode or in the insert mode by pressing I. Then I can do that. Otherwise, I can't. Then I will paste it here. So this looks good. I'll say I will say now we can start a screen. So screen is basically a way to run the commands on the remote server and not via the local terminal. What happens is, let's say there's an internet disconnection or there's a power failure and you are running some important command. What will happen is, since the local connection is cut, the Jupyter notebook will stop running on the remote instance, and whatever work you have done will also stop. In that particular case, it's wise to run uh, the Jupyter on that particular machine. And now we can say Jupyter notebook, and this should start running on this. Then we will copy this, copy the URL and add HTTPS port 8888, and hopefully it should run. Yes, so if you get this, then that means that you have done everything right. Then we click to advance and proceed to this, and we provide the password that we had put in the first place. Click login, and voila, we can create, let's say, a folder called code, and go in that folder. And let's say we are running a Python 3 environment because that's what we chose initially. And let's say this is the hello world. I'll say print hello world. And yeah, this is how we can set up the Jupyter notebook on EC2 instance. I hope you liked my video. If you liked, please subscribe to my channel and like this video. If you have any questions, feel free to leave comments and I will answer them uh, after this video. Thank you.